There is a question as a follow-up to factor theorem. So I'm going to call it factor theorem part 2. I'm given a polynomial that has one of the coefficients is missing. We don't know what it is. But we know that x plus 1 is a factor of this polynomial. Our job is to find the value of k so that this x plus 1 will be a factor of this polynomial. So we're going to apply the factor theorem and the remedial theorem. So we are going to find p of negative 1. We're going to do p of negative 1 because if you plug in negative 1, and if the answer is 0, then x plus 1 is a factor. However, we're starting with the premise that's saying that x plus 1 is a factor. So we need to plug in p, we need to find p of negative 1 and then set that to 0 because we know it's a factor. So it's 0 because there's no remainder. So let's try to do that, p of negative 1. So we're going to do negative 1 cubed plus k times negative 1 squared plus negative 1 plus 6. So negative 1 cubed is negative 1. And because it's negative 1 times negative 1 times negative 1 is negative 1. And then negative 1 squared is 1. So plus 1 times k is k. And then plus negative 1. And then plus 6. So this is going to be simplified to negative 1 plus negative 1 is negative 2 plus 6 is 4. So that will be k plus 4. But we know, like I said before, that if x plus 1 is a factor, then there's no remainder. Then that will be 0. P of negative 1 has to be 0. So we're going to say equals 0. All right. So to get k by itself, subtract 4 from both sides. So k has to be a negative 4. K is a negative 4. So now the follow-up question to that will be, what then will be the other two factors? How do we know we're going to have two factors? There's an assumption here that since this is a cubic equation, let's try to put it there. Let's put k back there first. So p of x will be s cubed minus 4x squared, because that's our k, plus x plus 6. So now that is our new p now, because we have just plugged in k to be negative 4. So we're back to the real function now, for which we are going to find the other two factors. So we already know that x plus 1 is a factor. X plus 1 is one factor. It's a factor. So what are the other two factors? Well, this is a cubic equation, so it's going to end up with 3 factors. X plus 1 times x times some, and then an x. So the factor will look like this when we are done. So we're going to find these other two factors. We don't know these two other factors. Well, in this case, we'll be forced actually to do the actual division. So we must divide to find that. So I'm going to use the reverse tabular method to do this because it's easier. So I'm going to divide this by x plus 1. So it's going to have a 3 by 2 table. Here is my x plus 1 over here. And then this will be s cubed which if I divide, I will get x squared. This is s cubed, and this is a negative 4x squared. This is the x, and this is the 6. So now, if I divide s cubed by x, I'll get s squared, and then multiply s squared by 1, I'll get x squared. Now, to get negative 4x, I need a negative 5x squared here. To get negative 4x squared, I need a negative 5x squared to add them together. So negative 5x squared divided by x is negative 5x. And then I can multiply negative 5x times 1 is negative 5x. And now I need something to add to negative 5x to get x. Obviously, it has to be 6x. 6x plus negative 5x is x. And then divide the 6x by x, I will get 6. And then multiply by that, I will get 6. So as you can see that I got 6 in the last cell over here, which is the 6 and the last term. So they are the same. There's no remainder. So remainder is 0, which is what we actually proved is 0. So now I can write my polynomial like this. I can write my p of x. This is my p of x now. My p of x will be p of x equals x plus 1, the first factor, and then this new factor we just found is a quadratic factor from the division. Okay, so here's a quadratic factor from the division. However, we know that this, we're going to try to factor it by doing simple factoring. So x plus 1, well, let's see. 1 times 6 is 6, so we can break this up into 2. To 2 and 3, so that we can get negative 5. Both of them has to be negative. So we don't need to look too far away. It's going to be x minus 2, it's x plus 1 over here, and then x minus 3. So now we have our polynomial in the factored form. So p of x, this is a factored form. The last question for this might say, now we can say, might say sketch the graph. The graph of p of x. So from this factored form, we can actually write 3 things. We know what the zeros will be. The zeros will be negative 1, 2, and 3. And degree is 3. And the leading coefficient is positive. So that means when we make our sketch, this is negative 1 here, this is 2, and 3. We know that if it's a cubic function, odd degree polynomial, it means that the end behavior matches that of just the basic cubic function, in which it's going to be starting from negative infinity and then ending at positive infinity. So we need to start from negative infinity, and there is no the multiplicity of each factor is 1, 1, and 1. So it just goes straight through like that, gets to the local maximum, and then comes back again, gets to the local minimum, and then continues again. This will be the factor. So I hope this helps a little bit. Thanks for watching.